Well, thanks for coming, everybody. This is a session called Our Snapshots Backup. Do we want to tell them how we came about with the session, like how we cooked this up?
Absolutely. I was presenting at the MVP Summit in spring here on campus, presenting SQL 2022 to the MVPs. That's a challenge, by the way. Try that sometime. That's okay. It was fun. It was an honor to do it. And in SQL 2022, we have some new snapshot backup capabilities. So somebody in the audience said, well, is a snapshot a backup? And it dawned on me, that's like the 6th time I had heard that question from different customers and now MVPs. So I'm thinking to myself, I might answer the question, but I'm thinking to myself, you know what? I need to ask somebody else. So been working with Anthony Yoon as well for a while. These guys, when I have questions on like backup technology and using storage, I actually talk to these people. So I'm like, what do you guys think? And we had a big, long diatribe, and that was back in like the spring, right?
Yeah, right.
And then Anthony pings me, I don't know, it's about a month ago or so. I'm like, Bob, let's do a session together on this topic. So that's when it kind of led to it, right?
Yep.
Are we going to answer it today?
I want them to answer it.
Okay, I got it. Yeah, got it.
That's the actual question. So I think Bob goes without introduction. Bob, you want to say hi?
Yeah, principal architect here at Microsoft. Thanks so much again being at the past summit. Man, it was such fun last night celebrating 30 years, seeing all the action, seeing the community get together again. I did an interview this morning for PASS talking about why are we here, why is Microsoft here, why am I here? And it is still about the community, guys, I'm telling you. So thanks so much for being here, showing this interest. And yeah, I'm excited to be with Anthony today. Again, Anthony and I go back. I did a book on Linux. He was my tech review. I didn't really know him. And I found out just incredibly intelligent, but also what a super nice person he is. So I'm honored to be here with you today, Anthony.
Thank you, Bob. There's another anniversary this year too, right?
What, for me?
Yeah.
Yeah, so about 2 weeks ago, I did celebrate 30 years here at Microsoft. I know that sounds crazy. Somebody to be at a company this long. Don't ask Anna Hoffman that question. Yeah. Because she wasn't born when I started at Microsoft. So she reminds me of that every day. So.
Cool. All right, let's get kind of moving. That's me, Anthony Nocentino. I'm a principal field solution architect at Pure. I help customers use our platforms to the fullest. There's a couple of customers in the room, been talking to a couple all week, but that's my job, mostly in the SQL Server and cloud space. Just to be clear, this is a vendor session, but we're gonna try to focus on the technology and capabilities. So we're gonna show the demonstrations on our gear, right? But yesterday I did the same session completely in Azure. So the capabilities that we're talking about today can function in other platforms as well, but we'll talk a little bit about why it's awesome on our platforms too. And so this is kind of the big bucket of topics that we're gonna go through today. We're gonna talk about what a full backup really is, what that looks like when you write out a backup. We're gonna dive into the T-SQL snapshot backup capability, the new feature, right? Talk about some use cases, and then ask that really hard question, is this backup? And we cooked up some best practices or recommendations around that. And so I guess one more time, Bob, do you want to talk about how we got here from a feature standpoint?
Yeah, it's an interesting history. When you're here 30 years, by the way, you're older, you tell stories. Maybe your parents do this, right? So being here this long, the whole idea of snapshots for SQL started with the concept of VDI backups. And so back in the 6.5 days, backup vendors were really popular, software backup vendors. And back then for SQL, we could back up to file, we could back up to tape.
There's still people that do that.
It's scary, right?
Yeah.
But also people didn't know we could back up to a named pipe, like a stream. And so these backup vendors said, hey, that's pretty cool. We'd like to take advantage of that. We want to take that stream of the backup bytes and then do with it what our software does, distribute it around, whatever. So can you build us a protocol? Yep. Hence the virtual device interface protocol came along. And then they said, by the way, storage technologies come along in a certain way where we can now do the snapshot concept of taking the actual files and logs and snapshotting them. How do we do that? And we're like, well, we could add something to the protocol, and we could add in the ability for SQL to suspend I/O to ensure the snapshot is correct and consistent. That's kind of the birth of how this all started. And then it's now led to, and we'll talk about here a little bit later, us creating a little bit better interface now with T-SQL in 2022.
Yeah, so one of the things I wanted to get into around that, and we'll talk a little bit more about VDI in a little bit, but any third-party backup provider that's getting a byte stream from SQL Server uses this interface. So it's been around for forever, and kind of taking that feature and adopting it into this. But let's talk about what a full backup really is. And so if I look at a database, any database, this could be one or many across many disks, but just in this example, I have a data file and a transaction log spread across 2 disks here, right? The red indicates the active portion of that transaction log. And so when I type backup database to disk, what happens, right? I get a checkpoint. I mark in the transaction log that a backup starts, right? I then create a backup file and I put a header on front of that. And then what happens after that is I sequentially read the pages from the database file and park them into a backup file. So I literally just pick it up and stick it into that file. If you attach a bugger or debugger, you'll see it just grinds on that over and over and over again until it finishes doing that throughout the entire database file or files, and then it copies the active portion of the log into that, right? And this is what a backup looks like. We mark that it's finished, we update MSDB, and we have a backup file now. But what do we do with this backup file? Then we have to protect it, replicate it, and do all those different things. But what if I could take out that step and just protect the data on the disks, right? And that's what we're going to go after today when we talk about our Snapshots backup. And what are some of the challenges? I'll just ask y'all. Let's go through this. Who's got a database over a terabyte? Almost everybody. All right, over 10 terabytes. About half of y'all. Over 100 terabytes. Right. So
she just went like this. She didn't even look. She was like,
right?
yep.
All right. So what are some of the problems that you have backing up a database that big? Right? Oh, time. Right? That's a big one.
The size of data.
Yeah. What about this one? Right? Who has a dedicated backup network infrastructure? Right? About 15 of y'all. So we have to do special things to back up these giant databases, because when we do these backups, what do? They put a lot of pressure on the resources of our system. CPU, right? Especially if you're using compression. Disk I/O gets consumed. The networking resources get consumed if I'm writing out to a network share. This gets to be a pretty burdensome operation. And so potentially can impact your workload. And there's costs associated with it too, right? I have to keep these backups, retain them, replicate them, and do all of those different things. If you're in the cloud, then there's real costs associated with that, right? The meter's going to spin a little bit faster when you're doing these kind of operations. But backups are cool, but really as cool as this, right, is restore. That's what we're going to try to go after. I mean, we get backups done fast because we can get back to going about our regular business, that whatever our databases are doing. But RTO, or recovery time objective, being able to get that database back is fast. Who thinks a lot about how fast their database restores are, right? It's a hot topic.
That's why they're here.
Yeah, exactly. Yeah. You want to dive into this a little bit, Bob? Or
What's that? I see this all the time. And actually, when customers talk to me about should I use snapshots, that's the first question I ask. What is your RTO?
Yep.
And when they say like, oh, well, right now my RTO is, unfortunately, RTO is dictated by how long it takes me to restore instead of what my business needs.
Yep.
They always talk about the limitation of the technology versus and start thinking about your business needs and then start looking at what this is possible.
Yes. And so let's talk about what a snapshot is, kind of abstractly, not necessarily like on our gear as Pure, right? And so when we take a snapshot, it's generally going to be a full read-only representation of the bits and the bytes on a disk or volume or collection of volumes. And then in Azure specifically, it's a point-in-time read-only copy of the VHD, or the Azure Virtual Disk, or disks in your storage, Azure storage. And on storage vendors like our stuff, it's a snapshot is a read-only representation of the data in a volume, right? And we can do some pretty cool things around metadata operations to do things like revert back instantly. Dramatic pause, right?
You're going to talk about what instantly means, right?
Yes.
Okay.
Yeah, and so we'll go through kind of the nuances of that. But I can also copy and clone a snapshot to another thing, right? I could present it back to the same database instance. I could present it to another database server in the same data center region or in a different region. And that gets to be really important because when we think about reverting a database back in time, what are we trying to do, right? If we have to bring the whole database back, that can be a challenge because there might not be a reason to bring the whole database back. But what if I could copy and clone it and just grab what I need out of it to put that back into the database, right? That's another workflow that we see customers use this a lot for. So the idea is, since these are metadata operations inside storage platforms, if I have a 20 terabyte database that's damaged, like maybe I dropped a table, or who's done a delete without a where clause, right? And I've ever done that.
No, don't say that.
Right, so in that scenario, what do you have to do? You have to go land a 20 terabyte database restore somewhere and then go get your rows, right? What's that take? Time.
Yeah.
And then I got to find the space to do that and call up the storage admins, and they're always cranky, right? I had to do it.
You had to throw that in.
Yeah, and then I have to go and I pull those rows back. But with snapshots, whether it be in Azure or on our platforms, I can leave prod up, clone the database back, and just pull out the rows instantly, right? Without having to land 20 terabytes or whatever the size or capacity of that is. And so you wanted to dig a little bit into this guy right here. So you want to.
So when we were creating this whole idea of doing T-SQL snapshot backups, should I talk more about why we need to suspend I/O, or are we going to cover that?
It's coming.
Okay, it's coming later, yeah. But this trace flag is part of it. So let me ask you a question. Has anybody ever opened up SQL Server on your laptop and tried to use Notepad on the data file? Just to grins, just say you'd hack it or something? Now, what do you get when you do that? What happens? But what's the error? Do you remember what it is? Yeah, you can't touch the file, right? So SQL Server opens their files exclusively, right? And so what we did in order to kind of test T-SQL snapshot backups is implement this little trace flag right here. Now, do not go on social media and say, I said to use this in production. It's just for testing purposes, so it's not fully supported. But it is an easy way to test a snapshot.
Yes.
Go start up SQL on your laptop, use this trace flag as a startup trace flag, and all of a sudden now you'll find that you'll get access to go copy these files directly while SQL's running. Now, it's dangerous, obviously, because you haven't suspended your I/O if you just try to do it, but we'll talk later about how does that fit with T-SQL snapshot backups.
Yep. Yeah, and the idea here, being able to copy those files to another thing to consume them. But in the storage tier, we're going to do that instantly, right, without having to do that byte-by-byte copy. But
and we'll synchronize with the storage tier to make this consistent.
Yes. And so let's get into that. Who's used snapshots before?
Oh, okay.
All right. I don't know when to ask this question.
Oh,
Who's had a challenge with snapshots before? Okay.
Everybody that raised their hand actually has.
Yeah?
So I just wanted to say that. So,
That's trouble. So let's kind of go across the spectrum of snapshots. I guess because the term's kind of overloaded. It's almost like virtualization.
A little bit, yeah.
So we have this idea of application consistent, crash consistent, database snapshots, and vendor-specific implementations. Let's kind of unpack what those mean. So application consistent really means is the database engine knows what happened in the snapshot, right? Yeah. And for years and years and years, we've had one way of doing this thing called VSS, right? The Volume Shadow Copy Service, which required either third-party tools to consume that service to coordinate the snapshot activity with the underlying storage platform. Who's used VSS before? Who likes VSS? All right,
what?
No one raised their hand for the recording. Right, because there's challenges around that. There's this idea of a non-deterministic amount of time for I/O freezes, right? And what's an I/O freeze do? That makes end users sad. And so we don't want to do that. We want to keep end users happy. And so that's one of the challenges of VSS for large systems, for high throughput systems, lots of databases. It's been a challenge. Crash consistent snapshots is something that our platforms specifically do very well. A database uses this thing called write-ahead logging, right? And as long as the underlying storage platform respects the I/O orders that are coming in from the database, then what's going to happen is we can always give you back a recoverable database, right? So as a DBA, you expect to be able to walk up to a system, pull the plug out, and plug it back in, and the database recovers, right? That's kind of what happens when you take a snapshot. I'm taking a point-in-time thing, and I'm just going to park it over here. And so in a crash-consistent snapshot, as long as write-ahead logging is adhered to, aka no caching of IOs or reordering of IOs on the way out, you'll always get back a recoverable database. But there's a challenge with this capability is there's no point-in-time recovery, right? And so the RPO of a crash-consistent snapshot is the snapshot, right? And so that means as a DBA, what do I want to do? I want to control the exact restore point with things like stop at, right? I'm going to restore transaction logs or differential logs to get me to an exact point in time. Database snapshots. I love asking this question. Who's ever used database snapshots? That's more than I thought.
It's not a bad feature.
I didn't say it was a bad feature. But there's really no portability, right? You're kind of locked into the instance because it's a construct of the underlying file system, right? And there's also some performance considerations around that with copy on write, right? And so
you make a ton of changes, it's like, why do it, right?
Yeah, exactly. And then there's kind of vendor-specific implementations with snapshotting a virtual machine or snapshotting a whole on-prem, maybe in VMware or Hyper-V or in the cloud. And really that comes down to kind of the granularity of restore. I want to recover back a database, not a whole VM, and have to go get the database. And so that's where this T-SQL snapshot feature was kind of attack, like go across all those different vectors and give us a way to consume this capability of snapshots, right? And I think this is the core thing, is the database is in charge of this, right? You talked about freeze and thaw. Let's kind of go get into that. The freeze and thaw is something that the database is completely in charge of. So it knows what's happening on the bits and the bytes that are laid onto the disk. And then once you freeze that database, we'll get into the semantics of this in a second in the code, but just kind of focus on the concepts for a second. is then we can coordinate an underlying storage level snapshot. So then the database knows what bits and bytes are laid out in the snapshot, which gives us a really core capability is this, point-in-time recovery. And then you get this, instantaneous restore of a database, a full database. So you can replace a full backup. Boy, I led too early with that. I gotta like soften it a little bit. But you can instantaneously restore a database, a full database, a group of databases, or an entire instance instantly.
So it's not a size of data operation.
It is not a size of data operation.
That's crazy.
Yeah, and we'll see this. We're going to see code, we're going to see demos, but just kind of hang on to that thought. So since we do have point-in-time recovery, what's that mean? I can put the database in restoring mode.
That's right.
Once the database is in restoring mode, we get to do some pretty cool things now, like that.
Yep.
Instantly.
That first one's amazing. So, but yeah, just email. See, people have asked me about this, by the way. They think with this technology, I can't do this, that I can't apply logs.
Right.
And that's a great myth to bust today about this.
We're going to go right after that. And so yeah, we're going to see a demo of seeding a 3 terabyte availability group instantly between 2 different storage devices. Okay. And this also enables cross-platform scenarios. I think originally, wasn't it called something else?
Yep, this is actually what we call it. We call it cross-platform snapshot backups because in the Linux world, we do have a VDI interface, but there's no VSS. There's no SQL writer, right?
I mean, Sava couldn't like make that happen, right?
So people could write VDI programs, but they had no way to easily do a snapshot. So we're like, how do we do this on Linux? And the team was like, well, we have all the code to just suspend things and thaw things. Let's just go in and create a T-SQL interface, because guess what? That's going to work the same across Linux and Windows.
Right, right.
That was the onus of it.
Yeah, so the idea is taking the freeze thaw capability from the operating system. And
which was in the
pushing it
VDI protocol already.
Was it really?
Well, yeah. So when you said a VDI snapshot to us with that protocol, because we built that originally, inside the code, we knew how to go do a freeze and a thaw, right? So we said, how do we just expose that through a T-SQL interface? We had to add some things, which you're going to talk about how you have to actually do a backup of metadata and so forth. But that was the onus of the entire thing, because that metadata, Anthony, used to be part of the VDI program's responsibility.
Okay.
Yeah.
Oh, interesting. So let's get into it. Let's talk about what a snapshot backup looks like. So if I have that same database that we started with, and we execute what's called a snapshot backup. Hang on, we'll show the code in a minute. We'll walk through that, but just focus on the process here. So if I say backup this database with a snapshot backup, I get a checkpoint, very similar to the previous operation. I tell the transaction log that we just kicked off a snapshot. We then freeze the database and log files, or file, that's another show.
Yep.
And then at the storage tier, we're taking an immutable read-only snapshot of the stuff that's on the volumes, right? So those bits and bytes are frozen in time. Then we create the metadata file that describes what's in those bits and bytes on the disks. We then thaw the database and log, and then the database can move forward in time, right? And so now I have this thing that represents the state of the database at the snapshot level. We marked that the backup's finished. Then we update MSDB. So we're going to go look and we do some demos. This is going to say full backup occurred. There's also a column that says is snapshot 2 that so that we know that this is a snapshot backup. And then I can couple this capability with log backups. And so now as I move forward in time, I just take regular old native log backups and can bring those two things together to do a point-in-time restore, which we'll cover in more detail in a second. But as promised, let's get into the code. And so we have to tell the database engine that we need to freeze a database, a group of databases. It says server. You know it's an instance, right?
Yes.
Yeah. So is Alan in the room? No.
I didn't write that T-SQL.
So the syntax, this is just a single database freeze, but you can freeze a collection of databases or a group or the whole instance. And once it's frozen, you have to tell the storage tier to do something. Right, and this is where we'll get into the demos. You'll see it on our code, and if you go and grab the demos from yesterday, you'll see it in Azure. Just coordinating that snapshot has occurred, right? And so it's the responsibility of the underlying storage subsystem to take that image that we're talking about. And then I run a backup with metadata. So here we have backup database db1 to disk. So you see db1.bkm. So that's this little tiny metadata file that has all the stuff that you'd expect in a backup header just here, right?
Real quick comment, you do need to protect that file.
We're going to get
Okay.
that. And then we have this new syntax with metadata only that tells the engine that this is a snapshot backup. Now, what I think is the best practice, and I think this is in the docs as well, is if we tell the database or the snapshot backup a little bit about where the snapshot is, if I have the backup metadata file and the location of the snapshot, it's starting to smell like backup, isn't it?
It is, a little bit.
And so what we're seeing here is I'm using the media description label to tell the storage or to tell me the name of the snapshot and where it is. So in Azure, this could be a URI to an actual Azure resource that is the snapshot, and then the name itself. And so if I have this thing and I build an automation, I can just restore the database, revert the snapshot, and go, right? We'll get into the details of that in a second. Yes?
If I'm using the snapshot for like scale out purposes, is it the read-only replica? Does it still need to take the backup data file?
So the question is, if I'm using a snapshot to make a clone of a database for scale out reads, not necessarily, right? As long as you take a crash consistent snapshot, which means the whole write ahead logging thing, would you really need point in time recovery to seed that clone? You may or may not, right? If you need point in time recovery, yes, you would need to do that. But if you, like on our storage platforms, when customers ask us that question, if I want to get a newer cut of data, just take another snapshot, right? Yeah, for that.
But just to be clear, that's taking a snapshot using like your technology where the crash consistent snapshot, that's not using this.
Correct.
But you can still suspend the I/O using this, which wouldn't give you crash.
You don't need to suspend I/O though for what
our
you're talking
platforms.
about.
Yeah, so that like in the Azure implementation, like if you look at the code from yesterday, this database is spanned across 2 volumes, right? Kind of the one we're talking about today logically. And what would happen in the Azure implementation is when I take a snapshot, I have to take a snapshot of the log database volume and then the log volume. Well, those are at 2 separate points in time. What this feature gets us is the ability to freeze that, so then at that exact point in time, both of those volumes are consistent, right? And then I thaw, it can move forward in time, because when I ask Azure to take a snap, it's taking 2 snaps, snap data, snap log. In storage platforms, there's usually a concept that allows you to group together volumes and then take an atomic snapshot of many volumes. And so most storage platforms can handle that without having to use this feature. Right? Excellent question. So let's talk about this metadata file in a little more detail. It describes what's in the backup, but you got to protect it, right? Because, right, you do this anyway, you're used to this, so just throw it in that file share that you're using today and let it go into your backup infrastructure. Or if you're using an enterprise backup system, you're used to kind of the same concept. I have a collection of things over here and some metadata that describes what's in the things, or AKA a backup catalog. And so your backup admins are used to protecting that as well. If you lose this thing, you don't lose access to the data, but you do lose point in time recovery. So if you lose the backup metadata file, you can just attach the database, right? But you can't put the database in restoring mode to get point in time recovery. One of the things I was doing for yesterday's presentation is I was writing a bunch of code, a backup metadata file comes out, and I take it and immediately throw it in Azure Blob, right? And so that's a good way to just kind of get this thing out of your data center as fast as possible.
And it's pretty small. It's so small, right? It's easy to keep these things around.
Yeah, tiny. 60K is for a single database.
Yeah, something like that, yeah.
And then overload that media description so that you can locate where your snapshot is. You can build automations around that. So, cool. So we focused on a single database example a bunch. And so let's look at another one. Let's look at a multi-database system. So if I have a bunch of volumes here and a bunch of databases spread out in a configuration like that, what if I wanted to do something like this? Right, snapshot's the subset of those. And you can do that. The backup statement would be backup group. You'd specify DB1 and DB3 in this case, and then boom, you take your snapshot. But I guess the question you have to answer is what happens to DB2, right? It doesn't get its I/O stunned. The other ones do, but you also just don't get point in time recovery for that particular database. So the question is why? Well, maybe you don't want that I/O stun for that particular database. In that scenario.
Anthony, would you, we were prepping this session, you used that word I/O stun, and I know what you mean there, but can you expand a little bit for everybody kind of what exactly you mean when you say I/O stun?
Sure. So when we're looking at kind of the idea behind the protection, or the multi-volume example a second ago, is the I/O stun really is to get what's on the bits and bytes in the storage to be what matches what SQL Server thinks it is. So to do that, we kind of have to stabilize I/O and then perform the I/O operation.
So stun in your mind is like, that's just a concept in terms to say that's the delay.
Yeah.
That's the stun you're going to take. So however long it takes to do that snapshot determines the length of the stun.
Sure.
Yeah.
Yeah, and so when we get into the demos, I'll time it. And in this particular demo, the stun for a database is about 800 milliseconds.
So it's not really a stun.
Yeah. It's like, would anyone even
I don't know what else to call it. Yeah, exactly.
Yes.
So if you're taking the snapshot of both the disks, you could still use that snapshot to restore the database to just not point in time because you didn't.
Correct.
use the TCP.
Yeah, the question is, if we do revert back in this specific scenario, we get point in time for DB1 and DB3, but not DB2, right?
Exactly.
Cool. And then just to complete the scenario here, we can do a full server.
Man, come on, man.
Man, you got.
I'll tell the team.
Yeah. Well, we can't change the syntax now,
It's true.
right? Yeah. So, and then we can do this at the server level to get all of the database. It's probably a more common occurrence than the group, right? Okay. So nobody cares about backup, right? We care about this one, restore. So let's talk about what a restore looks like using this capability. So let's say the database was damaged in some way. Like you gave me access to production, I dropped the table, delete without a where clause, physical corruption,
Yep.
Another one. And so what happens is we have the snapshot, we have the metadata that describes what's in the snapshot, and since this is a storage operation, whether it's in Azure or on our platforms, this is what it's going to look like. We offline the database, and then we offline the volumes, okay? And then we take a clone of those volumes and present them back to that operating system. And so we'll get new disks, but what's on those disks is from the snapshot, right? And this is occurring in metadata, both in our platforms and in the Azure platform. So there's no bits and bytes getting moved around other than some pointers that represent where the physical stuff lives in storage. And so when I want to go and bring that database back after I presented the volumes back to the operating system and online those volumes in terms of the Windows operation of online in a volume, we have some new syntax to restore a database. And so I say restore DB1 from disk. We point it to the metadata file with metadata only. And I want to put this database in restoring mode. So we use with no recovery. And so now, if this is a 1 terabyte, 10 terabyte, 100 terabyte database, this is an instantaneous operation.
That's crazy.
Yeah.
They're gonna when they see it. That's going to be the wow factor.
I know.
Yeah.
Yeah, so then I can go into restoring mode, and we can go ahead and play back some transaction log files, right, to get back to that point-in-time recovery that we want.
So what happens in the previous scenario where you had database 2 that wasn't backed up the same way as DB3, can you drop the volume up from underneath it?
Right, so the question is, what in a previous scenario I talked about DB2, and it was in a shared volume scenario. That's what we're going to talk about. You have to start rethinking about how we lay out our file systems and our disks to support the recovery patterns for the databases that are grouped together, right? And so not to say that you need a volume per database, but you're going to have to rethink about the coupling between the storage platform and where the database lives on the file system. Have you all thought about that
No,
internally?
that's exactly what you have to start thinking about because you haven't thought about before if you're not using snapshots, right?
Right.
You may not worry about that. I think the question is like in that case, you can just do a crash consistent. You're just attaching at that point, right? With recovery. You're not doing an actual process like this of doing a no recovery with metadata and rolling logs forward. That's just like attach the database and go. Because you didn't use this process to do that particular database. But you can still get it,
Yeah, your recovery point just was the snapshot.
just the snapshot at that point. There's no log restores possible at that point for you.
Cool.
There's a couple of questions, 2-3 questions. Go ahead, Ian. Yeah.
Yeah.
Just to be clear, so that if I've got 100 databases and one's corrupt, and I go to restore it, I take all 100 offline if they're all on the same line.
Right. So in our platform, so the question or the comment is, if I have 100 databases and there's one I want to bring back, right? You're going to have to rethink how your file layouts look. But in a storage platform like ours, and I don't quite know on Azure, so in FlashArray, it's data reducing, right? Meaning if I have 100 databases and I want to copy and clone those, I don't burn another 100 databases worth of storage inside our device. It's just metadata pointing to the same physical pages. So in that specific scenario, you could snap and clone and present new volumes as a new drive letter, right, or mount point, and then just attach that one database. And you're not burning the additional capacity, right? You follow me there?
Yeah, if you're going to restore it as something else, if you're going to restore it back to its original, that volume is offline.
Well, let's walk through that one more time. So damaged database A, right? And then B through Z I want to keep online, right? So I take the snapshot, leave B through Z online, and present new volumes, and then I just attach A and go. As a new mount point. Yeah. I shouldn't have used letters there.
It's a similar thing for Azure, same thing.
Yeah.
It's the same type of thing. I think there's a question here, and then there's also one over here. We'll get to that. Yeah, go ahead.
Yeah, so the question is that, say if I have an on-prem environment I want to use this Snap backup, what is the Windows, is this related to the Windows version or is it related only for the storage layer?
So the question is this a Windows-specific capability? No, I think it's cross-platform, and it's not even specific to a storage subsystem because the database engine is what's in control of what it thinks is in the snapshot. And so basically kind of decoupling those things from what we thought of before with VSS, right?
So to be clear about the SQL part of this, that's a SQL Server 2022 functionality. So if you want to do the T-SQL syntax that Anthony's showing you, how to do this, you would need that version of SQL Server.
Yeah.
Before that, you have companies that wrote VDI programs that did that same type of thing. You would purchase their software, or you'd write your own. There's actually an interface for it, right?
Yeah.
But do the SQL part of what we're talking about, you need SQL Server 2022, and it works on Windows and Linux. That's one of the reasons we did it. I think there's another one over here.
Yes.
Yeah.
When you initialize the snapshot, is it doing a full protection group snapshot behind the scenes on here?
In the code that I'm going to show, so the question is, when we execute this statement, is it actually taking the protection group snapshot in the array on our platform? No, and we're going to see that in code. So if you look at even the code examples for Microsoft, they'll say it's, you do this, and then you coordinate the activity with the underlying storage subsystem, and then you do the metadata backup. Yeah. And so, all right, let's do it.
Yeah, let's see it.
Right? Cool. So this is, am I in the right one? Yeah, the right one. I have a 3.5 terabyte database running SQL Server 2022, latest CU, I think CU9. And I'm going to use DBA tools to drive a lot of this capability. Mostly one, because I love DBA tools, but there's a technical nuance that I want to call out when we get into that. And I'm also going to use our new PowerShell module, PowerShell SDK2, to implement this. So the first thing I want to show you is, the instance is up and running, 3.5 terabytes. And I'm going to load up some variables that just for me to coordinate these activities between a SQL Server named AEN SQL 22A. I'm going to use remoting to do some work. But what I really want to call out is on what's on line 16. If I did this in PowerShell and I just used invoke SQL CMD, right? What's going to happen is I'm going to connect to my instance. I'm going to execute a T-SQL statement and disconnect, right? That's the default behavior of invoke SQL CMD, okay? When I execute the freeze statement in that scenario where I use invoke SQL CMD, what's going to happen is I'll connect, I'll freeze the database, I'll disconnect, and the freeze protects the database and immediately unthaws it after it disconnects, right? And so what I want to do here is I'm going to leverage DBA tools to build a persistent connection so that I can go do the freeze and I can move my program forward and do other activities while the database is frozen in a single PowerShell script. And so this is the challenge that you're going to solve or have to solve. And if you look at the code samples for the Azure implementation on the SQL samples, they use direct SMO or SQL Server Management objects to do this. And so just kind of reducing the friction point of us having to go and create SMO objects to coordinate this activity in PowerShell. So cool. So I'm going to use getDBA database to show you all how big this database is. So there's nothing up my sleeves in terms of size. That this is actually 3.5 terabytes. I think it is. Yeah, so 3.5 terabytes. So Bob made a joke years ago that I always use, and it's kind of popping into my mind now. So you said if you have to figure out where the commas are in a value, then it's probably an opportunity for performance
I did that in a
tuning.
keynote deal with Connor. Like if I got to figure it out, yeah, exactly. It's pretty big.
And I use that very often. I credit my source on that one. So we're going to coordinate the storage activity with the flash array, right? And so I need to make a connection to the flash array with our PowerShell module so that I can do certain activities. Remember, this is a multi-phase process. Freeze, do some storage stuff, and then back up the metadata. And so on line 32, we see that first statement where we're going to freeze the database. So alter database, ftdemo is the name of the database, set suspend for snapshot backup equals on in one of the pre-releases that equal sign wasn't there and broke all my demos. So,
We're good at that.
but I guess that's why it was a pre-release, pre-release candidate. So now it's frozen, right? And I used the verbose parameter there so you can see it. Now the database is frozen in time. So IO is frozen. I'm going to go initiate the protection group snapshot now. In our platform, where the protection group is the ability to take an atomic snapshot of multiple volumes at an exact point in time with one execution, right? Where if you did this in Azure, no offense, you'd have to go and talk to each disk and execute that snapshot. So there, the snapshot occurred pretty quick, and then we go forward and we take the metadata backup. And so you can see here, I'm writing the metadata backup file out to a network share so that I can use that on other systems. I'm adding in a date variable, and I'm also, you can see on line 49, I'm putting the snapshot name and then the flash array network location where that snapshot actually lives. So now at this point in time, when this executes, the database is stalled, right? So whether it's 1 terabyte, 10 terabytes, or 100 terabytes, you just got a full backup, right? But if it's really interesting is if you look at the output there, it's all zeros for throughput and the number of pages that are backed up. But we will look at how to do some replication in a few seconds, or actually in the next demo. But let's look at what SQL Server thinks. So I'm going to read the regular old SQL Server error log. There's the backup metadata file. That's 22K, so I was a little overestimated earlier when I said 60. Get the error log. SQL Server walks through. You can see this. Let me get this slider out of the way. But you can see from the time the database was frozen at 24 seconds, I was kind of talking in the demo. It didn't take actually 20 seconds, but if you executed that in one statement, which I will in a minute, you'll see how fast that is. And so at the end there, we can see a database backup occurred, successfully 0 pages processed, which is a weird thing to have. See,
It is a weird thing.
Yeah. And if I go
It
ask,
feels weird, doesn't it?
What's that?
Did you process any pages?
No,
Yeah.
actually you didn't. 'Cause
That's
you took
the
a
point.
snapshot, yeah. Yeah, and I can go look at the backup history. We can see that a full backup actually occurred. The database is 3.5 terabytes in file size, but there's about 1.5 terabytes in actual data in this database. And if I go and I crack open the backup header, I'm going to get all of the stuff that I would have in a regular full backup. So there we can see all of those things that are interesting. The file layout, so if you had to reconstruct this from an automation standpoint, you could read the backup header, create the volumes in your flash array or in Azure, and then bring the snapshots back that way. So you can actually get the previous config so that you know where you're actually restoring. Cool. And then once that, let's go ahead and, so apparently past Anthony was much more interested in those values than current Anthony, right? I can go ahead and take a regular log backup now. I'm using DBA tools again to do this because I love DBA tools, but also, I actually don't know T-SQL anymore because of them. Like really, I don't. So take a log backup, so there we see I have both of those on my system. And so let's say I do something like accidentally drop a table, right? Who's ever done that?
No.
Nah, I mean, no shame, we've all done it.
Not in production.
Right? Yeah, and then I go ask DBA tools for the last full and log backup, and we can see that those have occurred. Let's move forward in time a little bit. So let's go through the restore operation now, right? I could, I'm going to revert this whole database back to that previous state. And so I offline the database, which is what I would have to do for a regular full restore. And then I offline the volumes associated with the database. In this case, it's just one volume, just from a simplicity standpoint, but this could be n number of volumes if I needed to. I go ahead, and in this case, I'm reading all of the variables about where the snapshot location is on my network, the name of the snapshot, directly from the media header, right? So you can see that all there in the code. So let's go ahead and build that now to grab those two values. And then I could dynamically build the restore statement based off of that. So I don't have to remember those things over time, which I think is the core concept there. Fast forward a little bit. And so now let's take those, and we'll use this command, which is our command in our flash array, to take a clone of a volume, right? And so this volume physically is 20 terabytes. And so I'm going to go back and basically revert the data, or revert the volume to the snapshot at that previous point in time. And then I go and I online the volume, and I go ahead and run the restore command that we walked through in the presentation. So restore database, the key here is with metadata only, replace, and I'm going to put it in recovery mode with no recovery. So that was pretty fast.
That's very fast.
Yeah. So again, that could be 1 terabyte, 10
Wow.
terabytes, 100 terabytes. It
So that's
doesn't
what,
matter.
that was, you said it was 3?
Yeah, that was 3.
3 in 1 second?
Yeah. And so now I'm in restoring.
Okay, that's pretty cool.
Yeah. Come on.
Yeah, come on, that's pretty.
Yeah, well, they did it.
It gets better, right?
Yeah. And so now the database is in restoring mode, and now I can start blowing back log backups, right? And get back to that time before when I restored or when I deleted that table accidentally. And so now I go ahead and recover the database to bring it online, and our customer table is there, and I'm still gainfully employed, right? Yeah, so here
In seconds.
in seconds. So you're thinking, I have a snapshot. It's on a shared storage subsystem, right? We have 2 jobs, well, really 1 job as DBAs, right? Execute backups, get them on separate storage, and get them out of the data center as fast as possible, right? That's really core to what we have to do as DBAs, because I need to protect against media failures, I need to protect against data center failures, and things like that. And so we're going to talk about replication capabilities both in the Azure sense and on our platforms here in a few seconds. But let's look at how long this takes. So I'm going to take that snapshot code, and so here we see, go back a little bit. I'm going to freeze the database, I'm going to take a snapshot, and I'm going to take a metadata backup all in 1 stroke. I'm going to execute all this code at the same amount of time. And so when that runs, we'll see at the bottom here in the output that took 800 or 700 milliseconds.
Come on. So
Yeah.
you did a backup at 3.5 and 700 milliseconds.
Yeah, well, and the funny thing about this is
That's pretty cool.
We can actually shave this even closer because I'm coordinating
You
this.
can shave it further.
Yeah, I'm
Okay.
coordinating this work from a jump box in my data center.
Yeah.
So I have to go talk to SQL over the network.
Yeah.
I have to go talk to FlashArray over the network. And then I have to write this file out to the network. So if I really want to get that down further, I can just reduce those network calls and shave off a pretty good chunk of time.
The 700 is not fast enough.
No,
So, yeah.
I mean,
Yeah.
yeah,
That's crazy, man. That's awesome.
very cool, very cool. So any questions or comments around that capability? Oh boy.
Oh, wow. Here we
All
go.
right.
Here we go.
We're going to go from this side to that
Yeah.
side.
Start
Yes.
over there.
Are there any considerations for things like failover clusters? Sometimes those can have locks, they're called fuzzy locks and things like that. Is there any considerations for the test?
So as for the engine side, no, because they really don't care. For our platform specifically, there's no stun that's occurring at the storage level, right? So the question was, what's the impact of failover clusters and potentially availability groups? I think the consideration that you might be concerned about, if there was a storage level stun, then and there was an impact of the actual I/O path, right, and that was frozen, then yeah, the failover cluster would be sad. But in this case, from a failover cluster standpoint, the disk is up. It's just the I/O is idle at that point in time. And in our platform, we can take a snap without the failover cluster knowing.
For that small I/O stun time, that would not be a failover detection that would occur at the SQL level.
Yeah,
Even for an AG.
I showed this all to Joey D'Antoni, and he's slightly skeptical about things.
Yeah.
And he's like, let's talk about availability groups. And so I
Yeah.
went and I built that exact scenario, and same thing. So, all right, we're gonna go this
There was
way.
another one right there.
Yes.
What happens if I lose the original volume of data? Can I use snapshot backup in that scenario?
Yes, so the question is, if I lose the volume, like maybe a SAN administrator deleted the volume or somebody was, checked the wrong checkbox in Azure, yes. You would just create, in our platforms, you would just create a new volume from the snapshot. And in Azure, when you create the virtual disk, there's a parameter now that just tells you to use that snapshot. And so you can just bring that back at that point in time and create a new volume, right?
Can we do it on-premise also?
Yeah, so our devices are on-prem and in the cloud. And then Azure's, well, the cloud.
Yeah.
Yeah. It was one, yeah.
There are situations that can elongate that snapshot time, the freeze time.
Andrew. Yeah, so there's a checkpoint, right? And so the checkpoint's going to take as long as what? It's going to take, right?
But it depends on recovery interval and everything else you've got set, right?
Yeah, so you're going to find that if you're really using this capability, we're talking a little bit about best practices later, and how to minimize the impact of that, right? And that's kind of stuff that you're already kind of used to as a DBA, because I think the opposing forces here are checkpoint and then the active portion of the log and what that looks like from roll forward, roll back scenario. And we'll talk a little bit about that later.
But during the actual snapshot, it's the checkpoint that you see,
Yeah.
right? Yeah.
So for that, just run a checkpoint before you start all that, and that'll reduce that. But,
Yep.
For the snapshot, yeah, it doesn't affect the cluster, but if you're gonna restore it, you're taking the LUN offline.
Yeah, so the comment is, what's the restore scenario look like in a failover cluster, and also in an availability group too? It's kind of the same pattern. Yeah, you're going to have to unwind the clusterness a little bit, and we have some code samples online around that where you basically have to remove the disk as a cluster resource, do the snap back, and then inject it back as a cluster resource. And it's just a couple PowerShell commandlets, right?
Does the backup with the snapshot also support the encryption option and the compression option?
You want to grab
Well,
that?
no, because it's the storage level at that point.
Yeah.
So when we do a snapshot backup of T-SQL, you're not streaming your backup, right? You're just letting the storage vendor, you have the metadata, right? But we don't handle any part of the streaming part of it, so it's up to the storage vendor how that works, right?
Yeah, so if you're using TDE, or if you, like previously, do a backup with compression. So in a TDE scenario, it's just bits and bytes on storage volume that just happen to be encrypted. And the storage volume doesn't care either way, right? On the compression scenario, yeah, like you said, you're not streaming the bytes out, so there's no impact there. In fact, you're not moving any data, right?
So all those backup options aren't applicable because you're not truly creating a streamed backup. You're just creating a point in time and a metadata to say the storage folks have the backup. Yeah.
Yeah, so that's where things get a little bit interesting from a resource security standpoint. So yeah, RBAC is generally a way to solve that challenge. So when you start building restore workflows and runbooks and things like that, yeah, you're gonna have to be able to add or remove disks and do all those different things too. So yeah, let's do two more and then we'll keep moving forward.
Same question. Also, the topic is upgrade thing. But with my customers, they have all, I call this zero teams. One storage team, one DBA team, and DBAs are the best, yeah?
Yep.
But if I say to the storage team, give me access to storage, they say, no.
No, totally, yeah. So the comment is, and I live this life. I work in enterprise accounts and global, so I totally get it.
This is my question. How can you bring this idea to storage teams that they give the DBAs access to the storage?
Right. So the question is, how do I give DBAs access to storage, right? Show them the restore of a 100 terabyte database that's instant, right? And then go to the business and say, hey, let's talk about how we want to provide value to the company, right? But you're right, like there's challenges around that. And so storage providers need to have granular access controls in these scenarios. And so in our systems, we're seeing customers use things like Ansible and other tools to coordinate the work for that, right? What's that?
I say global administrator for all.
No. All right, one more, and then we're going to keep going.
I think right there.
Probably a complete new question, but like, how do I explain the difference to like our system administrators between this and like a VSS?
You want to grab that?
To VSS, you mean?
Yeah.
Well, VSS, you're still doing snapshot backups. It can be of the entire virtual machine itself, right? And SQL can be part of that. This way is actually separating out, in this particular case, just the database part, and doesn't require VSS. And that's kind of the reason we did it, is we wanted a way for you to use T-SQL and have a more way to control how you snapshot SQL backups versus having to go down that path.
So there's still an IO free that's just
Correct.
buried.
Yeah, because before I was saying that what we had before, the VDI method still had the same code to do the stun Anthony's talking about. We just took that surface area and said, let's put it in the T-SQL format so you don't have to go use that technology to do it.
Yeah, and I think the granularity is much more in your control now
Right.
because you can scope it to just a database or a group versus
The
having to
entire
just deal with the whole
volume
operating
section,
system. Yeah. Yeah, when I sat down with Pamela Hood, was PM for this, and when they were cooking it up, and she told, I didn't know this, but VSS, the underpinnings of VSS is actually VDI.
Yep.
Right?
Yeah. SQL Writer itself is a VDI program. So
Cool. All right, so let's go ahead and talk about the question that we want to ask you all.
yeah.
Right?
What do you think?
So what do we think so far? Is this starting to smell like backup? A little bit, right?
Okay.
I know what's in the backup or the snapshot, but let's talk about some other interesting scenarios. So if I have two SQL servers that are in the same data center, and I have another SQL server that's in another data center, right? In our platforms and in Azure, you're going to get replication, right? And so when I go and take a snapshot and I have my snapshot backup, right? We have one job, take backups and get them out of the data center as fast as possible, right? Or at least on separate media. In Azure, who knew that Azure disks are triple redundant in the Azure, well, yes.
Yeah, by default. But this is like local redundancy, right? Just triple default.
Just out of the box.
Yeah.
You know, LRS, right, means locally redundant storage.
Yep.
So each VHD or Azure virtual disk that you have, or snapshot, there's 3 physical copies in your Azure region, right? Did you know that? Yeah. So now I have physical protection of my disks and the snapshots associated with that within a region. And same thing on our platforms. You can very quickly replicate snapshots between flash arrays or between flash arrays and the cloud in a very storage efficient way. And so that's the other scenario, right? Is getting my stuff out of my data center as fast as possible. And so in Azure, we can copy snapshots between regions when we take the actual snapshot in the code that I have from yesterday's presentation, which I'll give a link to at the end here. But if I can do these operations and clone those volumes back and put the database in restoring mode, right? Now I have multiple copies in a data center and multiple copies between data centers. Right now, I'm starting to think that this smells like backup. But let's unpack this a little bit. Like, do you think customers should use snapshot backups as a primary strategy, or maybe?
Just the snapshot alone, no.
Right.
Because what you just said, you cannot rely on the fact that it's just a single point of failure. So when we had this big conversation, that was the whole part of the conversation was, it's great to get it fast and restore it fast, but where's your point of failure?
Right.
And that's kind of like what you're leading to at this point.
Yeah, and I think in our customer base, what I want folks to think about is this is a way to recover your systems really, really fast, right? And I never want to replace native backups because we're just solving for different problems now, right? If you have the 100 terabyte database, this is a good option, I think. Do you want to do this for every 1 terabyte database or 20 gig database? Probably not, right? But you can go back to your business for your tier 0 systems that are really large, that have been giving you pain for years, and use this capability to bring the system back. The other scenario that we want to unpack a little bit is how long do I keep a snapshot around for, right? Because in Azure that costs money, and on our platforms it costs space. And so we have to figure out like what's the retention interval of those snapshots, right? If I went to the business and I restored a database from 6 days ago, and I'm like, sorry, right? What's that mean to the business, right? So these on-array snapshots, and even the ones in Azure, I think, that retention interval is going to be pretty tight, right? Because this is the replacement of your full restore, potentially. But I'm still going to take native backups. I'm going to blow out a full backup potentially, and then replicate that to another site. Because what if I have to go pull a backup from 7 weeks ago or 7 months ago for a regulatory reason, or troubleshoot a data anomaly in a business process that's now failing, or numbers aren't balancing out properly? So we're solving for different problems with native backups versus using snapshot backups, right? Cool. So I just showed you this infrastructure where we can replicate between data centers. I can clone volumes back, and I can put databases in restoring mode. Well, we're about 3 lines of code away from making an availability group then, right? That's really cool.
That is very cool.
Yeah, so that database that we just saw, I'm going to put that in an AG. I'm going to replicate that between arrays nearly instantly, right? Independent of the size of data. So any questions or comments around like kind of backup strategies or anything like that, or availability groups before we get into the demos, team?
Yeah, so this is probably very stupid thing, but you have this replicate. I mean, after all, you're moving like 100 terabytes.
Sure.
It takes some time. You can move that to another data center.
Okay. So the question is, if I'm moving 100 terabytes between data centers, what does it physically look like on the wire, right? On our platforms, we have data reduction, right? And so on average, a database reduces 4 to 1. So that very first time, if it's a 100 terabyte database, I'm going to move 25 terabytes, like on our platforms. And in Azure, is there a similar capability?
There's similar capability, yeah.
Yeah, do you want to go into that one a little bit?
I don't have the details, but
All right,
I know that they do that, yeah.
Yeah, and so storage providers are getting smart about not having to move data twice. So if I come along and take another snapshot, the next one, right, after that initial 25 terabytes that represented the whole 100 terabytes goes, all I'm going to send is what's changed since the previous snapshot.
And Azure has the same thing.
Yeah, and this really has a massive impact on recovery objectives. In the scenarios that I talk to customers a lot about that have big, big databases, if I do an async failover of an AG, to a DR site, what do I have to do when I have to bring that back to prod? I have to bring the whole thing back,
Yeah.
right? And that's painful because it takes time. I got to sit around and babysit it for a couple of days. On our platforms, you just reverse replication, and we'll just send what changed back to prod. So that might be gigabytes potentially, just whatever blocks physically changed in that interval when you're in DR, and then just CDAG, which I'll walk through the steps of that in a second. Cool?
Yeah, pretty cool.
All right, let's do it. So, where's that demo? 1, 2, 3. All right, so this particular system is a 2-node clusterless availability group. No requirement there, I'm just telling you the lay of the land. And it's built already, but there's no databases in it. So I'm gonna have a database that's on this instance, and I'm gonna add it to this availability group. So there we see FT demo. That's the 3.5 terabyte one that we've been working with. I know that's a little bit small there, but there's no databases in the AG, and yellow on that dashboard generally means you need to pay attention to something, right?
But you're just doing clusterless, that's why
Yeah.
you're seeing that.
So let's go ahead and build up some parameters or variables to talk to the various SQL servers that are in the availability group. And this is on 2 separate storage arrays in the same data center in this environment. So I have a SQL server attached to one and another SQL server attached to the other. And so I'm going to take the snapshot backup of that database on the system that has that online database that's up and running. And then I'm going to take a protection group snapshot. And in this specific configuration, I'm going to force replication right now. And that's what those parameters do. And it tells our platform to immediately move that data between the 2 different storage arrays. So now there's 2 copies in the data center. That's it's in. And then I take the actual metadata backup. And now I have to go coordinate the work of getting access to that snapshot data on the other storage array. But the first thing I need to do, and this might be to your question, Erlen, is I need to make sure that that snapshot's there first. And so that's what this code is doing here. It's pulling that second array to make sure that that snapshot that I just took on the primary array is actually there and completely there, because that's the important part. I need all of the bits and bytes for that. And so there we can see in the output at the bottom that that snapshot replication finished about, what's that about? What day is it? 8 days ago. So you can tell exactly when I film these demos.
Yeah.
And then just to kind of double check things, in our platforms, we add an auto incrementing integer to a snapshot. So there we see it ends in .36 for both of those snaps. That's the primary, and then the other one is the secondary. So there's 2 representations now of this data in the data center across 2 arrays. And now I just do the work that we did a second ago to restore. So I shouldn't even air quote there anymore. It's actually an actual restore.
Yeah.
Are we close?
Yep.
So I offline the volumes on the secondary server, right? So the production database can just move forward in time. Like I don't have to do anything to that prod database. I then clone the volume, online the disk, and then I restore the database with metadata only, and that puts the database in restoring mode. And so now those bits and bytes are 2 physically separate arrays presented to SQL Server. One database is up and running on the soon-to-be primary, right? So we didn't have to interrupt transactions there. And now I just do a regular old availability group seed. I take a log backup. I restore that log backup on the secondary. Actual pages that time on the log backup. Yeah. I set the seeding mode on the availability group to manual because I don't want automatic to trip in, or to trip in, trip on, kick off.
Enable.
Yeah, enable, yeah. And then I add it to the AG.
Wow.
And then I start data movement. And now, when we go back into the GUI, you're going to see that that operation was instant, right? So imagine, first off, being able to do this to protect your business. Like that's the most important thing. I need to have to babysit or restore for 2 days, or however long it takes, right? So there we see the database is in the AG. It's synchronized on the secondary replica, and in a few seconds, the dashboard's going to go green.
And what was the size of that?
That's 3.5 terabytes.
Okay, that's pretty cool. That's pretty good. I'm always impressed with that demo.
And okay,
I'm always impressed with
okay.
that demo.
Can you close your ears for a second? Who loves automatic seeding, right? Who's had challenges with automatic seeding, right? For large databases, or many databases is really the challenge. So this doesn't have to be just one database, right? This could be a dozen or 2 dozen databases. And think about what that means operationally to you and your business to get your systems back in their HA posture faster. Or if this was between sites, get back in the full HADR posture faster, independent of the size of data, right? That's a crucial value here. And also, you can do the same exact demo in Azure. So if you go get the code from yesterday, this isn't specific to our platforms. We do some really cool stuff with data reduction and replication, but can happen in Azure as well. So I think that's important because, again, being able to get access to that data, build the AG is what's extremely important there.
Or get back to a disaster when you have AG set up, right?
Right.
Yeah.
Cool. Let's get into some best practices. So I think we covered this one pretty good. You don't like the I/O stun. Well, I mean, it's pretty fast, but just do it when you would take your normal full, right? When your users when they're expecting that to happen, right? Protect the metadata files, because that describes what's in your backup. In the AG scenario, you have to have the metadata files because you have to be able to put the database in restoring mode.
Anthony, quick point about the stun. I forgot to mention this earlier. You talked about checkpoints, and you're right about that. But think about what activities go on in your database. This is a write stun. So if you don't have a heavy transaction log workload going on, this is not a big affecting operation.
So it's just a write stun.
That's correct.
I didn't know that, actually.
Yeah. So, because we don't care, right? I mean, at that point, we can read everything on the disk. As long as you're not changing anything, it's only the write activity that matters. In fact, the most common wait type you'll see in this is write log wait.
Is on VSS, was that a whole stun, or is that just a read or write stun?
It's still a write stun. Yeah.
Just in VSS?
It's always about, if you think about it, we just care about the writes anyways. If you're just reading the thing and nobody's changing, it doesn't matter. So yeah, it's a write operation. So that's why you have to wait for this checkpoint. That has to occur, right?
Yep.
But from your application point of view, it's not super write heavy. You're not going to have a big impact to what's going on. Most apps do. So yeah. But anyways.
The other key part is if you want to make this part of a backup management, that's probably the number one thing there, right? Is replicating to other physical systems, other locations, other Azure regions to protect that data, and potentially other media types. Like our platforms can take snapshots and put them into object. So then you kind of start to meet other requirements for things like 321, if that's a requirement for your system. When you take a snapshot, there's an active portion of the log, right? So who's restored a database, and the database is in recovery mode, and your director or CIO is like, when's that gonna finish? You're like, I don't know, it's gonna finish, right? And so ADR, or accelerated data recovery, attacks that problem, right? It gives you constant time recovery of a system. And so when you take a snap, it's the same problem as when you take a full, right? The active portion of a log is part of the snap, it's part of the full, and it's gonna take as long as it takes. But you can use ADR to attack that problem, right?
How many people use accelerated database recovery today in their SQL servers? Cool. How many people do not know what it is? Okay, quick description, if that's okay.
Yep.
I actually wrote a LinkedIn post that ADR saves the world from rollback back in 2019. So we use this in the cloud by default to honor SLAs. The concept is turn this on your database, and now everything's versioned, all your changes in the database. So instead of like for example, snapshot isolation, are used to seeing versions in tempDB. So all the changes you make are now versioned inside SQL Server, which means when you do a rollback, we just have to go abort the version. So we don't have to do a true rollback. In fact, I did demos before where a rollback happens so fast I can't measure it inside an actual T-SQL statement. So don't worry about rollback anymore. That's happened fast, but it's all about undo recovery. You know the famous 1%, 2% thing, right? I did demos before where that's just gone because of this. Questions come around, what's the impact of this? Well, number one, it depends how many changes you're making. So we found like a typical TPCE benchmark could see even 3% impact or less. Something super write heavy is definitely going to impact on performance. Versions do take up more space, that's for sure. But the key is this undo recovery piece. Helps in this situation here when you're applying the snapshot. Also helps in an AG scenario when you fail over. Because when we fail over, we have to run undo as well. So that can be very, very fast. It's in SQL 19, also in SQL 2022, and it's a database option you turn on.
Yeah, I think that's an underutilized feature because that idea of being able to bring a database online instantly or almost instantly.
And we use it in the cloud for PaaS services by default, behind the scenes.
Very, very cool. Yeah, and the other idea is just making sure that you understand that snapshots cost something, right? Space on your arrays, or you have to swipe your credit card in the cloud. And also considerations around data file layout, right? We kind of touched on that. That's going to become part of your restore patterns And it's only for user databases, not system databases. But I
Right.
mean, I think we're trying to attack big data problems. Hopefully, I mean, some of us probably have a 100 terabyte MSDB, right?
That would be interesting.
Yeah. Junior DBA Anthony had figured that out the hard way.
Okay, did you? Okay.
Oh, yeah. And this is interesting, too. You can only snapshot primary AG replicas, which
Yeah.
means you have to code around that when you're using snapshots, because now it's a storage level operation coordinated with database activity, right, or database stuns, meaning if I take a snap of a previous primary that is now a secondary, it's actually going to say that you're going to get an error from T-SQL that says, no, you can't do this, go snap on the primary, right? So you're going to have to code around that and know where your volumes are when you're taking that snapshot, right? So, all right, let's ask the question, Bob.
Yeah, I think we should ask. I mean,
All right.
we've done this, so let's see what they say.
What do y'all think? Does it start smell like backup? Yes? Maybe? Cool. Who doesn't think?
It's a backup.
Yeah.
Does anybody?
We could talk afterwards if you want. Uh-oh.
Yeah, go ahead. Challenge us.
You'll hear about snapshots, right? Users like call around or something, will bring up corruption almost immediately.
Okay.
Not protecting against corruption. So how do you address that?
I mean, it's fair. I mean, if there's actual damage at the actual snapshot at the disk layer itself on the files,
Right.
you're just snapshotting the corruption. There's no question. But you're also doing it with a backup. If the pages are damaged on disk and you back up to a stream, you're just backing up the corruption itself. So, which is why if you had like an AG scenario, right, which is separate disks, even if you've got maybe corruption here on database pages, the other AG standalone replica would not potentially have that, right? So you're right. If you just do a snapshot backup and there's damage actually at the file level itself, this is no different, but it's the same thing if you did a full backup of that same set of files. But why did Paul, I'm just out of curiosity, what did Paul say that this isn't good, or what was his comment? Oh, okay.
Yeah, I vaguely remember.
Okay. Yeah, you're definitely snapshotting the problem if it's damaged at the disk level, for sure. Which is why, again, why some people have other mechanisms to keep copies of their data, like an AG replica, where it wouldn't exist on the other drive. Yeah.
So, one of the things when you're making full backups through the API, you are running, you're accessing all the bits in the database you can check, running the check, so like
When you do a snapshot backup, you do not do that. There's no checksum option. So you're not checksumming pages at all. Correct.
Another question, when I do a metadata backup, does reset things page in?
For differential?
Yeah, for differential, is there a copy?
No, I don't believe so.
Yeah, it does.
Oh, it does?
Yeah.
It does? It resets it? Okay, well, it does. There's your answer. He's done this more often than me.
So is there a copy on the syntax if I want to use this?
Oh, a way to not do that?
There is, the question is there a copy-only syntax? Yes.
Oh, okay.
Yeah.
Oh, you mean for the snapshot?
Yeah.
Okay.
Yeah, so when you do the backup
To make sure you don't
database-
worry about the chain?
Yeah.
Okay.
Yeah, and so that's where it kind of become part of
I haven't tried that.
the different recovery strategies there. That's a great
Okay.
question. Yeah, so like
good to
replace is on there. There's a bunch of options that are on there that you're traditional stuff. And I think that's the other key feature is that you're using tools and techniques that you're already used to. Obviously, we have to fold in the storage part of it, but it's going to be...
So Anthony, the options you're used to for things like that exist, but things like compression, and that other stuff doesn't matter because that affects.
Right.
So whatever affects the stream isn't there.
Right.
What affects maybe how the backup affects your operations, that is there.
Yep.
Okay, that's good to know.
I don't think you can overemphasize the alone layout enough because most scenarios you're going to have multiple databases, and if you got to take them all offline, to do that, or you're going to have too many. So I think you really, really have to engineer this correctly for it to be truly useful.
Yeah, and I think, so the question, or the comment is, this adds to your volume or LUN layout complexity because that becomes your restore point. Yes, it does. So mount points will be your friend, even after being a foe for the last 20 years. But I think it really goes back to what you're trying to achieve, right? Is that, am I going to go do this for every database in my data center? Maybe not. But the big giant ones that have caused me grief over the years, I think that's the challenge that we want to go after. Oh boy, I saw, yeah. That's my buddy, Andrew.
Oh no.
You mentioned that we can't take these on secondary replicas on AGs.
Correct.
We've got customers that even with the small amount of IO3 that's really off quite important, would there be any consideration of Microsoft to make this available for us to freeze IO on secondary replicas?
I'd have to even go look at the technical there could be a technical reason behind we don't allow that. So I don't know the answer to that question. We'll look into it. Contact me and we'll talk about it.
Yeah, we so the comment was being able to take
From a secondary,
enabling
yeah.
snapshots and secondary replicas. There's some interesting edge cases around that we could probably discuss maybe offline. One more, and then we're gonna go ahead.
In a perfect world, it all be on SQL 2022.
This is a big one.
Well,
Yeah.
well, yes. Oh, wait, are you saying you are not? I'm just kidding. Sorry, just kidding. Yeah, question. Oh, are we going to backport it?
Yeah, are you going to go backwards on that at all?
There's no plans to do that right now. Sorry.
That would be awesome.
Not that I'm aware of. What's that? So there is a SQL feedback site. I know people think we don't pay attention to it, but we do. I get an email every time a certain amount of votes comes from that site.
Is that right?
Yeah, we do. I do.
What's that number?
Well, I'm definitely not going to reveal that. But yeah, put it on SQL feedback, but no, I don't, right now, there's not certainly plans for it.
So I guess to that question, a little bit is we have this available for you all to play with right now. We have a platform called Test Drive, which is a virtual lab that you can go log into to go and touch all of these things on our devices. So you'll get access to a couple flash arrays, a couple SQL Server instances, to go do all the things that we just talked about. Point-in-time restore, seeded availability group, and we also have some additional capabilities in there based off the new S3 object integration. So that's all available now. So you go to that QR code, you sign up, you'll get an access code, and you'll have a virtual lab to go do all of these things, right? And so I'll leave that up for a little bit, but anything you want to close with, Bob?
No, I think the only thing I want to say is that every time I've talked about snapshot backups with 2022 is I never talked about it before. I never brought it up, actually, because it was this VDI-based interface that used volume snapshot service, which people didn't really like. And a lot of people weren't really to go write a VDI program or purchase another software company that used it. So this is a feature that's been on SQL forever. And all we've done is just kind of open up the interface now. And I distinctly remember when this first came out, people like Anthony going, what? We are going to go, what does Patrick LeBlanc call it? We're going to go bananas on this, right? So, and we've seen it. Not just Pure, but other organizations that have storage providers as well really got involved with us here. So my ask for you is just go back and think about this. Think about all the things Anthony talked about, your core job, what you do. I love the way you described that. Our job is to get the database backed up, then get it out of the data center, and then really focus on the timing here. You talked about the challenges with different organizations in your company. We're not dumb. We've worked in companies. We understand that we talk to companies. But go back and present a business case. How quick do we need to get back up in a case of a disaster? And could this technology make a difference? If you're already using Pure Storage, look what you already have available. You're right, you got to go to 2022 to take advantage of the T-SQL part of this. But there's some huge advantages of doing it. And so this is one of the reasons we put the feature in there. It was a very often asked request that snapshots be kind of a first-class player for SQL, and we kind of think this did it.
Yep. And so I appreciate y'all coming. All the code is on my GitHub repo right now for both FlashArray and all the Azure stuff. And so if you go to that link there, you'll see a folder on GitHub for past Summit. You'll see the two different representations of how to do this work, and just go test it out, please. Good?
Thanks for having me, Anthony. I appreciate it.
Thanks for being awesome, Bob.
Thanks, everybody.
Thank you, everybody.